Hello everyone, welcome back. So in this video, we will discuss the problem bottom view of a binary tree. So in this problem, given a binary tree and we have to print the bottom view from left to right, and a node is included in a bottom view if it can be seen when we look at the tree from the bottom. And for this binary tree, the expected bottom up view is 5 because 5 is the leftmost node, and this is also the bottommost node, and then 10, 14, and then 15. These are the node which is visible to you if you look at the tree from bottom. And there might be a case when you have a multiple bottommost node for a horizontal distance, for the same horizontal distance from a root. In that case, we have to print the node which is letter 1 in a level order traverser of the binary tree. So for example, in this binary tree, 3 and 4 both are at the horizontal distance of 0 from the root node, and so in such cases we have to print 4 because 4 is the this node 4 is a letter node in a level order traverser. Cool. So this is the expected output 5, 10, 4, and 14, 25. So let's see how we can solve this problem. So this is very standard problem of a binary tree, and the logic that we use is to assign a unique value to the root, and then use some formula to assign the values to the left child and to the right child, and every column I will assign some value. So we can start with any value for this root node. So assign value 0, and then for every node, let's say this node is having value hd means horizontal distance from the root node, and here I have started with 0, but it can be any constant number, and then assign the value to its left child hd minus 1, and for the right child value minus plus 1. So minus 1 for the left child and plus 1 for the right child, and you can use any constant in a place of 1, but make sure to use the same logic, same formula for all the other nodes. So 0, then its left child is 8, so 0 minus 1, which is equal to minus 1, and plus 1 for this 22. Then the left child of this 8, which is minus 1, which is equal to minus 2, and right child, so minus 1 plus 1, so which is equal to 0. Cool. And yeah, this is the intuition, because root node and this node 3, they both are in the same column, so that the minus 1 and plus 1 will get cancelled out, and both the nodes belong to the same values. Then left child of this 3, so 0 minus 1, which is minus 1, and for this 22, 1 minus 1, which is equal to 0, because 4 is also in the same column as this root, and then plus 1, so 1 plus 1 2, and then 0 plus 1, which is equal to 1. So now one thing that you can observe here, all the node which are belonging to the same column, all the node which are belonging to the same column are having the same value, same horizontal distance value. So we can use a map data structure. So we can use a map data structure, but you can also go with an unordered map. It's totally up to you. But the time complexity in the worst case of unordered map is linear because of the collisions in the hash table. And this map, which internally uses red black tree and ABL tree, has a time complexity log of n base 2 in every case, in the worst case also, where n is the number of key values pair in this map. So first I will store hd as a value, and then int. So int, here I will store the value of a node. So node value. This hd is a column number of a node, and this int is a node value. And whenever first there might be a case when we have more than one node in a same column and in a same row, that is the same hd values and at the same level. So in such case we have to print the node which comes later in a level order traverser of this binary tree. So for that thing, what I can do, I can visit the tree. First I will process the left subtree, then I will process the right subtree. Cool. So for every node, first make a call for its left subtree, and then make a call for its right subtree, so that the new value will get updated, and this previous value, which is 3, will get replaced with the 4, and this is something that we want. So I guess this was enough explanation. Now let me just quickly show you the implementation. So first of all, I have declared a answer vector, and here I am having the map. So the where the key is a HD, that is horizontal distance from the root, and this int is a value of a node. So here I am using Q to implement the level order traverser. And for a root, I am assigning a value. For a root node, I am assigning a value 0. That is the value of horizontal distance is equal to 0. And here is this queue is a pair, and where the first element of the pair is a node itself, and the next element, which is horizontal distance from the root, is 0. So starting from 0, and it's basically simple level order traversal. While queue is not empty, then this is the front node queue dot front. So this is a front pair, and then I will remove this pair from the queue, and this is a horizontal distance, basically in second value of a pair. So temp dot second is a horizontal distance of the current node, and the current node is temp dot first. Then I am simply assigning the values. So I am simply updating this map. So map of HD, that is this HD horizontal distance is a key, and the value corresponding to it is current data, current arrow data, and then I am checking whether its left child is null or not, and if it is not null, that is this expression evaluates as true. So in a queue I will simply make a pair of left node and the horizontal distance, which is hd minus 1, and similarly same thing I am checking for the right subtree, and if its right child is not null, then make a pair current arrow right, and the horizontal distance would be hd plus 1. Cool. And after this BFS traverser, after this level order traverser, I can just simply iterate over all the key values pair of this map. So for auto I in MP, then simply I am adding the value of I dot second, the value of key value pair in my answer vector, and finally I am returning this answer. And since map has a property that it store the key value pair in a sorted order, so that's why the sorted in a form of sorted from left to right. So first of all, this will get stored in our answer vector. Then we simply store this one, because this is the this node is having the smallest. This node is having the smallest horizontal distance. Then this 10 is having the smallest horizontal distance. Then first I will store 3, and then later on I will simply replace this 3 with the 4. So this 4, which has the third smallest horizontal distance, so minus 1, then 1, and then 0, and then 1, basically this node, and then 2. Cool. So you cannot use a unordered map, because unordered map does not support the property of being sorted, and map support the property of being sorted. That's why here I am using the map, so that we can print the bottom view from left to right. And the time complexity of this problem is n log of n base 2, because here we are using map which add a logarithmic time complexity, and the space complexity, so linear for this vector, and the linear for this queue. So overall the time complexity is linear. So let's try to submit this. Cool, got accepted. So thank you so much.